Okay, when is your guys' final? Do you remember? Oh, it's Thursday? Okay. If any of you guys want to take a Tuesday or Wednesday, there's so few of you. I don't care if you all would just move it to Tuesday or Wednesday, then we can just not come in. That would be great.
What time on Tuesday? Because I have one at
I'll tell you.
1 o'clock that I cannot skip.
No, I think it's early. The Tuesday one is at 11, and the Wednesday one is at 9.
I'm booked to both of those.
Okay, well, you guys all, that would be my preference, but if you are just a diehard, I want to leave it till the last minute, I will come and sit with one of you to take the test on Thursday. Maybe I'll even email out your class, but if you guys know which one of those you want, just email me. Do you want me to tell you the numbers again?
Yeah.
11 on Tuesday,
Okay, I have one during that.
okay, or 9 on Wednesday.
9 to.
Just an hour.
Oh, it's just an hour?
Yeah.
I'm at 11 that day.
Okay.
So, Wednesday.
So if you know which one you want, just drop an email right now before you forget and say, I will take my test Wednesday at 9 or Tuesday at 11
Do we have to take them during those times?
or Thursday at 10:30, which is your,
Okay.
or 10. Did I say 10:30? I think it has to be 10:30 because like,
It's 10:30 to 12:30.
yeah. Some of them, like the one that says 8:30 to 10:30, I just said we're doing it at 9. We're not doing it at 8:30. So yeah, 10:30. If none of those work, 10:30 on Thursday. Okay, so so Monday's a practice day. Practice exams Monday night. So this, as I'm doing it with people and doing the practice problems, this is super helpful. This literally covers 95% of the calculations in chapter 17 and 18. So 95% of the calculations from the test, obviously not concepts. You start by asking yourself, is there one chemical in there or did you mix two of them together? So if there's one chemical, then you just decide, is it a strong acid, strong base, weak base? And then it tells you how to do the calculation. I only get you to either H3O plus concentration or OH minus, because then you can use this chart. Okay, so you know if it's OH minus, you're probably going to do POH and then get to pH if that's what it's asking for. If it's H3O plus, then you can just go straight to pH. Okay. If it is two compounds, two chemicals, that would be like you have a buffer, right? That's the first example here. You have a buffer, so you have a weak acid and its conjugate base. That's basically like saying the same thing as a weak base and its conjugate acid. They literally are the exact same. But if it's a buffer, then you have a certain approach. If it is a strong acid and a strong base, you have a certain way to do it. If it's a weak acid or a weak acid and its conjugate base plus a strong base, or a weak base and a strong acid, then you have a different approach. I know those four seem a lot more complicated. Here is the easy way to think about it for these two compound ones. If you have only weak stuff, so to start, you always have to do a dilution. Two compounds, you always got to do a dilution. That one is like for sure. If you only have weak stuff, then you skip a consumption step, you just do equilibrium. So weak stuff needs an equilibrium. Strong stuff needs a consumption. So if you have just strong, you just do consumption steps. If you have just weak, you just do equilibrium. If you have a combination of the two, then you have to do both. Okay? So just weak stuff, equilibrium. Just strong stuff, only consumption. Weak and strong, consumption, equilibrium. Okay? No, you cannot use this chart on the test. But as you can see, there's a lot of like repeating themes that if you do enough practice, you will understand what you're doing. It's just a way to organize your thoughts. Okay? That is the best advice I can give is weak stuff, equilibrium, strong stuff, consumption, combination, you got to do both. Okay? All right, so we're going to do these. We're going to go back to titrations that we were doing on Monday. And we're going to do these using that chart to kind of help us along. So we stopped at a strong acid, strong base titration. So coming back up to where we started, it said consider the titration of a 25 ml sample of 0.22 molar nitric acid, so a strong acid, with 0.13 molar NaOH, a strong base. So two things means we need to do a dilution step. Strong with strong means consumption, no equilibrium. Okay? So calculate the initial pH before any NaOH is added. Okay, well that one is just one compound, so we didn't have to actually do all the involved stuff there. We just did negative log of the acid. When we got to this one, where it was two things together, strong acid, strong base, we first did a dilution, then we did a consumption. No equilibrium step because there's nothing weak there, so you don't have to worry about that. Okay, new one. Calculate the volume of NaOH needed to reach the equivalence point. This is one of those 5% that's not involved on that sheet there, okay? Volume needed to reach the equivalence point, and then what's the pH? So, at the equivalence point, moles acid equal moles base. Okay, that is the definition of equivalence point. They are equal, equivalence, equal. Okay? And the easiest way I've come up with telling you how to calculate this is you're gonna do the molarity of the acid times the volume of the acid, and you're gonna set that equal to the molarity of the base times the volume of the base. I have had people forever say, oh, you can just use the dilution equation. Well, it's not dilution because you're not mixing these two things. You're saying they're equal to each other. When I changed out 1 and 2 for acid and base, I felt a little bit better about it because the dilution equation technically works, but not because it's a dilution, just because you're saying the moles equal to moles and molarity times volume is equal to moles, so it works. So this is fine to think about it like it's the dilution equation. Just substitute those subscripts for acid and base, okay? And because this is, never mind, I won't tell you that yet. I'll let you guess on the pH, okay? So go ahead and plug in the molarity of the acid, the volume of the acid, and find out how much base we need to get to the equivalence point. Ugh. I told Walmart that I would bring my own bags and I didn't put them in my car. Now I'm gonna have like all these loose groceries in my car.
Tomatoes.
I know. Jars of salsa.
Sounds dangerous.
Kicking myself. The beginning of the problem.
Um,
Sorry. Yep. So this whole like 4 slides is all based on this one titration.
okay, because it's been a couple days.
I know. I did scroll up there earlier. We did look at it. It's
Well,
just,
think,
yeah.
but I fear my memory's not what it used to be.
No, I'm saying we looked at it like this morning.
Oh,
At the
but I
beginning,
did
I said,
connect them.
okay, yeah.
I did connect them.
It's okay. So we're titrating 25 mils of 0.22 molar. So that's what's in our flask. In our burette is 0.13 molar NaOH. And we're saying how much volume do I have to let out before it turns pink? Meaning we've hit the end point, which is moles acid equal moles base. Okay? So I did 25 times 0.22. And then set that equal to 0.13 times the volume of the base to get to that point where they're equal to each other, which is 42.31 mils. So that means, you know, it makes sense that it's a lot more than the acid because the acid is more concentrated. So it's going to take a lot more of the base to add it. So, strong acid, strong base, the pH at the equivalence point is always 7. Okay? You are adding exact amounts of acid and base, and they're both strong, so there's no equilibrium there, so they just basically make water. So the pH is 7. You don't need to do any calculation. If you tried to, you would do a consumption step, and then you would see that they were equal molarities, and they would both turn into water, and then you would see there's no acid or base to use. But save yourself the time, it's just 7. Okay, using those same molarities, calculate the pH after the addition of 50 mils of NaOH. So we just said 42 is the equal point. So we are now past the equal point. Doesn't actually matter. We still approach it the exact same way. We've got 2 chemicals, strong acid, strong base. We're going to do a dilution step. We're going to do a consumption step. Okay? I wrote that note in there to remind you about what a consumption step means. Use up the smallest amount. So whichever thing is in the smallest amount, that's what you subtract off and then add to the other side. Not minus X and plus X, just minus whatever the smallest amount is. Then you look at what you have left over to determine the pH. Okay, so do that for this one. Dilution, consumption, and then see where you're at. I like to start by writing the equation before I even do the dilution because I don't know, because then I'm like writing down the dilution under the chemicals, which is then the starting amounts. So you can write that as HNO3 and NaOH. You can also just write it as as H plus and OH minus. I am tired, but I'm not going to use that as an excuse. I have no reason to be tired. I've slept like plenty. I just feel like I'm old. I saw it was funny. I swear I'm not on social media this much, but I did see this funny like Instagram thing that was like, people say to me like, oh my gosh, you're almost 40, your life must be so boring. But I just saw a raven and a cardinal eat out of my bird feeder. And I was like, yeah.
Okay, but like I saw a goldfish this morning and I was so delighted. I saw a goldfish this morning. Like,
Okay, so you can be 40 and apparently not be bored of life. I don't know, maybe by 40 you'll be bored of birds too, and then what do you do? You'll follow in your mom's footsteps and garden.
Probably. I don't know. I've always been into bird watching. My mom says I was 80 when I was 2. But, yeah, I picked up watercolor then.
Yeah.
Oh, yeah,
I heard he made a comeback for like putting people to sleep or something. Like as a soothing, it's like a meditation thing.
he sounds like meditation science.
Yeah. I mean, I remember him as a kid. All right, stop talking. Do your thing.
Yeah, really focus.
Point to dude. Okay, so how do we do the dilution? What is that new volume? Somebody tell us. Like what should be on the bottom here? 75, thank you. So it's whatever the two together are added, so they should be the same for both of them. Okay, let's all make sure we're to this point and then feel free to go on, but I'm gonna wait and talk through it with people before I go on. Okay, let me just say something first before we finish it up. Let's look at the curve. So we were doing calculations here on Monday. Then we did this one just now, this morning, and now we're doing one up here, okay, after the equivalence point. These are pretty much the same approach. If you looked at a list of like, how do you handle calculations before the equivalence point? How do you handle them after? It's going to talk about them like they're very different things. And there are little minor things. But as far as our sheet of how you approach them the same. You're mixing two chemicals. In fact, you would approach this one the same too. You're mixing two chemicals. You do a dilution. You do a consumption. So like on this one on Monday, we did that. We did a dilution. We did a consumption. The difference is before the equivalence point, the base is the thing that's in the smallest amount. You haven't yet matched up the base and the acid. So we're subtracting off the base and leaving behind some acid. In this one, the smallest amount is now the acid. So we're gonna subtract off the acid and be left with some base. So you still follow the same routine. It's just you need to recognize when you get to the end, you have base left over, which means that's the concentration of OH minus, not H3O plus. Okay? So now concentration of OH minus is 0.014, whereas in the 2 ago, we had the concentration of H3O plus as our remaining amount. So we could just take the negative log of that to get the pH. If it's after, we have to take 14 minus the negative log to get the pH. So I'm gonna go back to that decision tree thing. It's not a tree because it's not like a flow chart, but okay, so this one is 12.15. This should make sense. We're past the equivalence point. The equivalence point was 7. When we were before the equivalence point, we were at like 1 or 2. Okay, now we're past the equivalence point, so we're just adding base, so it's getting more and more alkaline. Okay, so back to this sheet. Strong acid, strong base. We did the consumption step, used up the smallest amount, which in this case was the acid, and then it says whichever acid or base is left, use that to determine the pH. So if it's a titration and it's before the equivalence point, you're gonna have acid left. If it's after the equivalence point, you're going to have base left, but the calculation is the same. Okay, any questions before we move to a weak acid, strong base?
I've done this calculation and I wouldn't know what to do.
Okay, well, let's do it together then. Good. Wait, you're saying you've done those ones or the ones we did? Do you feel more like the weak acid ones? Okay. All right, good. Well, at least you were introduced to it. Yeah, okay. All right, so because one of them is weak, we know there'll be an equilibrium step. Because one of them is strong, we know there'll be a consumption step. So that means we're gonna have dilution, consumption, equilibrium on all three steps on these calculations. Now, notice that it says weak acid plus strong base, which is a titration. It also says or weak acid and its conjugate base. That is because this calculation we're about to do is virtually identical to if we were to add a strong base to a buffer. So we did this calculation on Friday. It is the exact same calculation that we did on Friday. We're just thinking about it as a titration, but it's the same as a buffer calculation. Okay? Dilution, consumption, equilibrium. And the equilibrium, we really just mean the Henderson-Hasselbalch here. Okay, deep breath. We got this. Okay, here's the curve. We're going to do, again, initial pHs. We're going to do some where we've added before the equivalence point. We'll do the equivalence point. We'll do after the equivalence point. Same general calculations, but this one is one compound, and these ones are two compounds. Okay, so the first one, ignore this sort of, because we have kind of our own method now. Okay, so these are the numbers we're going to start with for all of these. It's acetic acid. They should have given you the Ka. I should have given you the Ka. And it says calculate before any NOH is added. Okay, so this is not two compounds to start. This slide is just one compound, just the acetic acid. That's it. So when I look at my sheet, one compound, it's a weak acid. So I need to just do an ice table with the Ka. So this is why, like I said, this is chapter 17 and 18 calculations. Because when we have just that one thing, that's just chapter 17. So it's a good review. An ice table with the Ka, just that one compound. Looks like this. .105 molar minus X plus X. We have a nice small K though, so I can get rid of that minus X. Do these look familiar? I know it's been a while, but it's actually the easier of the calculations. So go ahead and solve for X and solve for the pH. Olivia, you look like confused.
I think I just put something wrong with my calculator.
Anybody else get this? Because it's possible I did too.
Because I got 0.00137.
I also got that.
137? Okay, well, it was me then, guys. It was me. Times 10 to the negative. Wait, did I say fifth or eighth? 1.8 times 10 to the negative fifth, right? Okay.
I also put 8 in my calculator and was like, that's not right.
Okay, hang on. So then square root of that. Oh, 0.105, not 0.15. That's what I did. Okay, good catch. 00137, right? That's what you said? That's what I have at least. 0.00137. Okay, so 2.86. Good? Okay. Calculate the pH after the addition of 12.5 mils NaOH. Dilution, consumption of the smallest thing, because one of them's weak, now we need to do an equilibrium step, which I will always only do ones where you can use the Henderson-Hasselbalch as your equilibrium step. Okay? So I'm going to write the equation and start working on it, but you guys go ahead and work on it on your own as well, following those 3 steps: dilution, consumption, equilibrium with Henderson-Hasselbalch. That's a 6. Oh, come on.
0.05 for the
Which one?
initial for the NaOH. Instead
Hmm.
of 0.043, we have 0.045.
Okay. Divided by 36.5. No, you're right. I think I might have put 35 in there because I kept like reading that as 35. 36. Point. Yep. 445. Okay. Oh, and now that subtraction's wrong. Ugh. It's not my day. And this is the point when you guys are like, yes, but you're not the one taking the test. Okay. All right, somebody check me. 5.02, 1.8 times 10 to the negative fifth, plus the log of 0.045 over 0.024.
4.9.
4.9.
That's what
That seems a little further off than I would like, but I bet you that it would be right on the test because there wouldn't be another one that close. If you had a number, like if you had 4.9 and you had one that was 5.02 and one that was like 4.8 or something, I would double check your work and make sure you don't round anything. So like if I had rounded, like let's say I put 0.07 instead of 0.069 and 0.04 instead of 0.043, that might have been enough to get you to a pH of 4.9. So just try not to round too much until you get to the end, obviously. But it's close enough that it sounds like you're doing it right. Okay, questions on this one? All right. Calculate the volume needed to reach the equivalent point. What is the pH? Okay, so again, same thing as before. Moles acid equal moles base. Then for this one, because it's not strong, it's not going to be equal to 7, you need to do all of the same steps. You're mixing two things now. It's just that now you'll know the volume. First, you have to figure out what the volume is, then you'll know the volume, and you can do dilution, consumption, equilibrium.